Hello, and welcome to another meeting for the Information Security Club at the University of Calgary. I'm Emily. You've probably seen me in the background before or in speaker series, and tonight I'm going to be running you guys through an introduction to cross-site scripting. So before we get going, there are a couple announcements as usual. First of all is the attendance sheet. Make sure that you sign it as usual. You need to sign attendance in order to be a voting member, and the AGM is coming up at the end of the term. Also wanted to remind you guys that not next Monday, but the Monday after is the next installment of our speaker series. So we're going to be featuring Adam Mcmath, who is a cybersecurity expert in Calgary. He's a really cool guy. I think you guys are really going to enjoy what he has planned for you. It's going to be interactive. It's going to be fun. It's a little bit of a workshop, and Adam is just really fun, and it's going to be a good one. So that's for members only. If you haven't paid membership fees, that's okay. You still have time. We've prorated membership fee for this semester, so it's only $5 for just winter semester, and that will give you access to all of the upcoming speaker events. The final announcement is the CTF, just a reminder that it's live, that you can go to the Eventbrite page to sign up. It's open to anyone at this point. You don't have to be a student in order to sign up, although it is geared towards beginners. So if you've joined our club and you've followed our workshops and you're thinking like, yeah, I know I've followed along, but I don't really know like if I'm ready to jump in and do a CTF, you are ready. This is for you. Go sign up. It's going to be good. And that is February 19th to 21st. So it's coming up quick, and we want all of you guys to be there. So I think that's just about it for announcements. We're going to jump into cross-site scripting and see how it goes. So just, okay, attendance link is posted. Awesome. So I'm Emily Baird. This is cross-site scripting. We're just going to do an introduction today. What do you need? Well, you need a web browser. This one is really easy. You don't need to be installing anything. All you need is a web browser, which is also one of the things that makes cross-site scripting kind of insidious. So our goal for today is, first of all, to go over kind of a brief overview of JavaScript. We've done a little bit of web exploitation before with James's workshops, and we've done a little bit of SQL injection as well. So most of you guys probably know a little bit about the interplay between client and server, but today we're going to add JavaScript to the mix. Then we're going to move on to actually running some cross-site scripting attacks ourselves. First of all, we'll do some smoke tests, some really easy, basic examples. And then after that, we'll move on to some actual attacks. And what I hope you guys come away from this workshop with is an understanding of why cross-site scripting is dangerous, and hopefully how to prevent it. So the big question here is, what is cross-site scripting? First of all, it's just a really common type of web exploit. So if we head over to the CVE list and just search for XSS, already in 2021, this is what the CVE list looks like for cross-site scripting attacks. It's really common because it can be really hard to catch as a developer, and because, as we'll see pretty soon, JavaScript is everywhere. So it's common. It's become less common in recent years as people have learned to prevent it. But it's still really insidious, and it's still really a good thing to know how to protect against it when you're writing web code, and it's good to know for CTFs as well. So in some ways, it's similar to SQL injection, but in other ways, it's really different. And it basically relies on the interactions between JavaScript, which is a client-side code, and server-side code, such as PHP. So I mentioned it's kind of like SQL injection in some ways. that's because we're going to attempt to do something similar where we craft a payload that tricks some kind of code into being executed. For SQL injection, we were trying to craft a SQL statement that maybe commented out part of the query and added other parts. Today, we're going to be attempting to write JavaScript. However, unlike SQL injections, the goal of an XSS attack isn't to attack the server, it's to attack other clients. All of the web exploits that we've done so far have attacked servers. Cross-site scripting is a little different because JavaScript runs on your computer when you load the web page. We're not going to be attacking the server. We're going to be attacking other users. So to start off, pretty basic introduction to JavaScript. It's a programming language. And the important thing is that it can sit inside web pages. So we've all seen some HTML and some CSS at this point. You can write code into your HTML by including it in script tags like these, or by linking to it in a separate file, the same way that we link to CSS. Question from Jeremy first before we move on. What is the CVE list? It is common vulnerabilities and exposures. It's basically a list of known vulnerabilities with write-ups about how they were discovered and how they should be patched and what versions of different software are vulnerable to those attacks. So cve.miter.org, which I'll post in the chat, is a really great resource for finding known exploits and known vulnerabilities, and for checking if something is running outdated or vulnerable code. So back to cross-site scripting. You can write code into your HTML. So this is an example. Here we see a couple of different ways of including JavaScript on a web page. First, we have a link to an external source of JavaScript. So this is jQuery. It's a JavaScript library. Next, we have a script to JavaScript that someone has written themselves. It's linked on a separate web page. And finally, we have some JavaScript that's been written on the page itself. So this is inside the body tags of the HTML. This is where the actual HTML is written. And there's a script tag opened, JavaScript inside, and then the script tag is closed. So JavaScript introduces logic to web pages, which is how we get dynamically generated content like animations or personalized streams. Basically, any dynamically updated content in a web page is using JavaScript. And that means that JavaScript is everywhere. It comes in lots of frameworks and packages as well. So there are things like Node.js, or Angular, or Vue, or React, or even React Native. So writing apps in JavaScript and then compiling them down to the source language for iOS and Android. So this is really cool, but it's also kind of dangerous because it means that all of these sites are capable of processing JavaScript, and JavaScript is literally everywhere. Anything that you can do with Python or C, you can do with JavaScript in a browser. So our goal for today is to get someone else's website to run our JavaScript. Just before we go on to the first challenge, some basic JavaScript functions that are really helpful to know are console.log. So this prints a string to your console. If you remember from the other workshops, if you're on a web page and you hit Control-Shift-I, you can bring up this developer toolkit. And if you click over to console, you can send and receive messages through the console. So console.log will log something into the console. There's also alert, which just pops up a pop-up on your screen, and it's so annoying and in your face that it can actually be really helpful for determining if something is vulnerable, because it's really easy to see if your pop-up has worked. Another question, are these frameworks different from one another? If yes, what are they? That's a good question as well. So different frameworks are used for different purposes. Some, like React, are used for front-end stuff. Others, like Node, can actually be used to run JavaScript on your server side so that you can do everything in JavaScript. Other than that, some of them are just libraries that provide different functionality. And like I mentioned, React Native can be used to create things like apps for iOS and Android, and then you compile them from JavaScript to the language that's needed for either iOS or Android. So my first question to you is, on a secure website, if you attempt to fill out a form and you give it this as a string, what should happen? Well, I'll tell you what shouldn't happen. This. If you say console.log hello world inside a script tag, and you just send that thing off as a string, absolutely under no circumstances when you hit enter on that form should you see hello world actually load into your browser. You should never see JavaScript actually execute if you write the code in the browser. Instead, this is what should happen. So you start off by sending a dangerous character, something like the opening bracket that could be opening a script tag. Nothing or invalid input. It depends. So some sites may just say absolutely no way, you can't put those characters in here. That was invalid input into the form, try again. Other sites might do what I'm about to explain here, which means that you can write things in there that might look dangerous, but they never actually get executed, in which case the form would get filled out successfully, but nothing would actually execute. Return that it's improper output. Yeah, potentially. And this is the alternative. So if you want your site to be able to accept characters or strings like this, but you don't want people to be able to XSS you, then this is what you would do. So first, the user inputs a dangerous character. The server turns it into something else. This is an HTML entity that represents the same character, but it isn't actually dangerous. And then when it sends it back to you and displays it in your browser, you get a visually identical character that doesn't actually mean anything to JavaScript or HTML. So in the end, you could send something that looks like this, script console.log, but it never actually executes this because JavaScript only cares about opening and closing brackets. It doesn't care about and less than semicolon. XSS vulnerabilities occur when this process goes wrong. So we're going to jump into some examples. We have a web page up for you today. I will drop the IP address into the chat. So on this page, we have a couple of different exercises. And then there's also some resources that you might find come in handy. But we're going to start off with the very first one. It's called Where There's Smoke. Just a note, I know that a couple people recently have been working ahead and just barreling through challenges at their own pace as fast as they can. The later challenges on this site, number 3 and number 4, won't actually work, and you won't get a response until we get to that point. So if you already know everything about cross-site scripting and you're about to jump ahead, don't. It's not going to work. The exploit won't go through. But if you guys want to take a look at where there's smoke, your goal here isn't to get a flag. The first couple ones we do are going to let you get your feet wet, but they're not actually going to have flags involved. We'll get back to that in a minute, the reason why. Your whole goal here is to prove to yourself that this site is vulnerable. So do something to this site to force it to run your JavaScript. Just as another note, if you want some more explanation, there's an exercise explanation down here if you want to read a little bit more. And then there's also a section for a hint. So I'll give you guys a couple of minutes. Let's say, I don't know, 5 minutes. This one's pretty easy, so I think a lot of people will get it quickly. As usual, feel free to text in the chat when you have it, or if you're stuck, or if you want to ask a question of me or your fellow club members. Go wild and see what you can find. I'm gonna put Alex on the spot and and bring up uncaught reference error, flag is not defined. What was your payload, Alex? And my question is that really worth the darn it? Feel free, if you're still working, to toss a number in the chat, where 0 is, this is super easy. This is like, come on, chop, chop, let's get moving, to 9, which is, this is crazy hard. I don't know what you're talking about and I need help. All right, we're getting some 0s in the chat, which I think means it's time to move on. Let's go through this really quick, and let's see. Alex posted the payload that she used to get uncaught reference error, flag is not defined. And the point, the thing to notice here, for just some unfamiliarity with JavaScript, 3s. All right, yeah, I think you guys are got the basics at least, or the idea of what we're trying to do. So Alex put console.log flag.txt and got an error saying that flag is not defined. But the reason I said, is that really worth a darn it, is because this JavaScript shouldn't have run at all. The fact that Alex got an error means that it ran and crashed, but it never should have happened in the first place. So that actually kind of served the purpose, which is that we were trying to prove, hey, this is vulnerable. Let's take a look for ourselves and give it a shot. So if I hop over to where there's smoke, put in a name, put in an email, says, hey, Emily, thanks for registering. We'll be in touch. But if we go back and say, open a script tag, close the script tag, and in the middle, alert 1, and hit sign me up. Sure enough, we get an alert. That never should have happened. So this is called a smoke test. We weren't actually trying to get anything out of this other than to prove that the exploit could work. All right, so that one was pretty easy. Let's bump it up a notch. So we want to put this into a place where users can input information, and then we wanted to try to send something that the server didn't expect. In our case, we use JavaScript. You could also potentially use HTML and just change the way that the page looks. If it's doing the filtering, where it turns that less than or greater than sign into a different symbol, then HTML won't work either. So if you can run HTML, that's also a good sign that this might work. Some of you guys tried console.log, others tried alert, and you wrapped it inside the script tags. And we already went through the solution. So next up, we're going to go on to the second one. Sean says, also looked at exercise 2 and had no clue how to do it with only numbers. That's what we're going to get into now. And Braden says, have to love that uni XSS filter. Yes, the University of Calgary Wi-Fi doesn't like it when you try and XSS websites. So we're going to do a quick introduction to post and get requests, and then we're going to try and mess with them to sneak past what Sean was hitting and send another payload when we really shouldn't be able to. So the basics of HTTP requests are that when you load a web page, you send a hypertext transfer protocol, HTTP, request to the server asking for the files associated with that page. You send a request, you ask it for a particular page, you maybe include some extra information about who you are and where you're coming from. And then it sends you back the HTML and the CSS and the JavaScript that you need to view that page. So here we were trying to access infosec.calgary.ca/test/demo form, which I don't think is a real page. You might have also noticed that this said post here, and that's because there are multiple ways of formatting HTTP requests. The two big ones are post and get, and what they both allow you to do is add variables into your request. So you can refine your request with variables and their values. For a post request, we request the page at this particular location, and then we send information about the variable and its value in the body of the request. We might talk, or you might see in CTFs people using tools like Burp Suite, which can intercept these requests, and you can edit and change these values. Then we also have GET requests, which can send the same information, but the difference is that you send the variables and the values by tacking them onto the URL at the end. So if we open YouTube, and just search for something, we can see that when we actually sent the request for this page, we included a variable called search query, and we set the value of search query to be hello world. Then the server used that information to send the data back to us that matched our request. So on PHP, on the back end, it might look something like this. So the method on the form is a post that tells it when you hit the submit button to send the information using a post request. And it defines a variable called name, or called email. And then whatever you place in here will be the value. When the PHP on the server side receives it, it will see, it will check to see if it was a post request and if the email variable was filled out. And if so, it can use the value in that variable to change what it displays. So when you did that first example, what you were essentially doing was you were telling the server when it filled out the rest of this form with the value of the variable, you were telling it to fill it out with something like this, which is how the attack actually ends up running JavaScript on your browser when the server does all this processing and then sends it back to you. So with that information in mind about post and GET requests and how they're formatted, we're going to hop on over to exercise 2, which is called Get Good. This time, it's the exact same thing. You just need to prove that the vulnerability exists. There's no flag here. The difference is that this time, you can't actually change the values to whatever you want. All you can do is pick a date on the date picker. However, there is a way around it, and I'll give you guys maybe 5 minutes again to see if you can figure out how to get past it. We'll hop back to this page. On a scale of 0 to 9, how are you guys doing? How are you finding it? Yep, I'll give you guys some more time. I'm seeing some 0s and some 1s, but also some requests for some more time. In Discord, I'm seeing some people with some incredibly unusual birth years, including something about potato salad. That's a good sign. I'm gonna give you guys just one more minute. If you feel like you're getting really close to an answer and you're not quite there, let me know and I can extend it. Otherwise, at 6:40, we'll call it and move on. Muted. What a 2021 mood. Let's take a look and see if we can't bypass this this calendar requirement to do some XSS nonsense. So from here, it seems that we're only allowed to pick dates. 2021, whatever. When you hit confirm age, though, up here in the top bar, we can see that it's sending this data as a GET request, which means that the data is out in the open and we might be able to mess with it just here in the browser. So it appears to have a variable called user bday, and it's just setting it to whatever we got in that calendar. But if we try and put something else in here, user bday equals hello world. It lets us in, even though that's input that shouldn't really be allowed. It says you were born in the year of hello world, and somehow the year hello world is also eligible for the closed beta, so that's bad. What if we put a script tag? What is a script tag? And an alert in here. Oh, look at that, JavaScript. And mysteriously, you were born in the year of nothing, JavaScript pop-up is also eligible for the closed beta. Very good security. So at this point, we've done some basic requests with both post and get. We've done some basic smoke tests. So this was working because it was sending it in a GET request. There are also programs that you can use to modify post requests, but it's a little easier to see when it's a GET. Okay, so we're just about at the halfway point. And what you guys might all be wondering is, why does any of this matter? Like, I've been attacking myself all night. I've been sending myself JavaScript. I'm not really sure how that can make anything vulnerable. And frankly, you'd be right. The stuff that we've done so far isn't really dangerous. You're just making your own life hard by giving yourself pop-ups. However, XSS ramps up really quickly from funny to dangerous. You can do things like keyloggers. You can intercept every keystroke that another user makes and send them back to the attacker's server. You can steal cookies if a website is using cookies to determine whether a user is logged in, or a session ID. You can steal those too. You might even be able to redirect victims to a different page that they don't know is fake, and then convince them to input a bunch of sensitive data and then pick it up on your keylogger. Basically, JavaScript is a fully fledged programming language, and not only does it have the capabilities of doing anything that you can do with Python or C, it has access to all of the data in a user's browser. So anything in your browser, information about you that's stored in cookies or session IDs, all of that stuff is available to JavaScript. And if you can get your JavaScript to run on another user, you can get that information too. Especially in CTFs, a common goal is to steal a cookie. So there's kind of like a prototypical Ctf XSS challenge. Normally it will have some kind of user input field where you can try to put a payload, and you'll be told somewhere on the page that an admin or a moderator will review what you send, and your goal is to attack that admin when they load your submission. So as per usual, don't actually attack the organizers of CTFs. But the goal here, again, is to attack another user of the web page. And in terms of CSS, or in terms of CTFs, that typically happens when they just flat out tell you, they're like, the admin will check your submission. And if you ever see that in a CTF, it's a really good indicator that what you're about to try is a cross-site scripting attack. So just a forewarning, these ramp up in difficulty quite a bit from here on out. So if you get stuck, that's okay. That's to be expected. That's why the hints are there on the webpage. It's also why the resources tab is there on the webpage. Feel free as well to talk in the Discord or to ask questions in the chat. This is going to need a more complicated payload than alert 1. Luckily, we have a couple of tools to help. The first one is just a general really good tool to use, not just for XSS, but for all kinds of attacks and all kinds of CTF challenges. It's a GitHub repo called Payloads All the Things. The link to it is in the resources tab. And the XSS injection side comes with a whole bunch of built-in payloads to try. Most of them, you'll need to modify them a little bit to suit your needs. But this is just a really great tool for CTFs in general and for cross-site scripting tonight. So your goal for this one is to steal a cookie from this this poor unsuspecting archaeologist. I'll give you guys a little bit longer for this one. Please feel free to say in the chat if you're stuck or if you want help. I'll try to provide some hints along the way. But you guys, if you're willing to do a little bit of research and dig in, you should be able to find a starting point for a payload and then craft it to suit your needs. And if you get really, really stuck, remember that there's more stuff on the resources tab that you can also dig into. So this one, we're probably going to take about 15 minutes. Keep me posted. Let me know how you're doing. Before you go for the full-fledged attack, also feel free to try a smoke test first. It's always good practice. I've told you guys that this site is vulnerable, but it's always a good idea to at least double check. Also, by the way, I can see all of the payloads that you guys are sending. Keep that in mind. This one might not give you super clear feedback if you try to use the alert as your smoke test. All right, so we're coming up on just about 10 minutes for this challenge, and I want to get a feel of how you guys are doing. I'm seeing lots of smoke tests come through. I'm seeing a couple people get really close. And I want to know, are you at a spot where you're like, want more time, you feel like you're making progress, or do you feel like you're stuck and you're just dropping stuff into the box with no idea what to do? All right, hearing some requests for a little bit more time, as well as some requests of people just putting things in and not being sure. So I'll give you a bit of a hint to start off with. If you want to just keep working away, that's also fine. So if we head over to the resources tab, and actually we'll just hop over to payloads, all the things. The goal here is to modify something on this page to give us a little bit more control. So this is something that we've done in previous workshops, although it's been a while. And if you head over to the resources tab, you might find some stuff that you can use to take advantage of a URL that might be a little more helpful to you than some of the other stuff you're getting. My other hint to you is to read the hints and to think about how the interaction works between the client and the server. So when the browser comes back and loads the JavaScript, what kind of information does it have? What kind of information do you want? And how can you get that information to a place that you either control or you can view it with a little bit more clarity? All right, so I'm seeing lots of people get pretty close, but I'm also seeing your guys' responses slow down. So I think that means that it's time to move on a little bit. I want to give you guys lots of time to work on the final challenge. So let's take a walk through and see if we can see. Oh, I literally just saw someone get the flag. Let's take a walk through and see what we can find. So we know that the goal here is to steal a cookie from this definitely sane archaeologist, and we also know that based on the webpage and what I've told you guys, this person that we're trying to attack is going to visit the page. So they're going to get whatever input we put in here, and if we can send them a payload, we might be able to XSS them. If we head over to payload all the things, it's all sorted by the kind of attack you want to do. And if we look for cookie, we can just grab one of these and start trying. So obtains the administrator cookie or sensitive access token. The following payload will send it to a controlled page. That sounds like exactly what we want. So let's grab this. And paste. Now, I've seen a lot of people, I've seen a lot of requests come through that are trying to send the admin to http:/localhost/xss/grabber.php. And if you tried that, you were on the right track, but you probably weren't getting any results. That's because localhost is your localhost if you're sending it, or my localhost if I'm the admin who's receiving it. But the whole goal here is not just for you to get the admin to go somewhere and to send the cookie along with them. The whole goal is to send it to somewhere that you control so that you can get that information back. If we take a look at what's going on here, document.location should redirect us to a new site at this location. Here's the URL, http localhost. And then we can see that it's got a GET request coming in as well. The variable that we've defined is called C, and the value is document.cookie, which should send a list of the name value pairs for all the cookies in the browser. So that's cool. We can redirect and we can get it to send the cookie along with us when we do redirect. But where do we send the cookie to actually get it somewhere that we can use it? If we head over to the resources page, this is something that we've used before in the club, things like pastebin or request bin. This is a site, inspect HTTP requests, that gives you a URL, and it will collect any requests made to it and let you inspect them in a human-friendly way. So if we create a request bin, we should be able to see all of the incoming requests that come in to into this URL. So if we head back, instead of trying to send it to http localhost xss whatever, we'll take this out and send it to our request bin that we control. And when it goes, it should set this GET request and send document.cookie along with it. Let's try. Thank you for your opinion. And if we head back over to our request bin and refresh and take a look at the request that we got, we can see that a request came in. These were the headers that were included, and these were the parameters or the variables that were sent along with it. So we got a random session ID coming from the script that is checking your guys' solutions. And then it got a cookie called Is This a Flag? With a value of UC_sec hand out of the cookie jar. So I would encourage you guys all to try that, to spin up a request bin and give it a shot. I'll give you a couple of minutes to try it, and then we'll move on to our final challenge. I want to leave a lot of time because, as you guys probably discovered, this gets pretty tricky pretty quick, and I want you guys to have enough time to really dig in and try some stuff. Alex said, I never even looked at the localhost part. I just changed blog.php. Yeah, that's a good point. Normally, when you're grabbing stuff from a source like payloads, all the things, sometimes you've just got to like try changing bits and pieces to make it work for you. In our case, the document.location is sending us to a place. And for me, with cross-site scripting, it really helps to kind of put myself in the shoes of the person receiving the request and thinking like, okay, what is this actually going to make their computer do? And how is it actually useful to me if I'm trying to pull off this attack? All right, so let's keep moving on. You guys can keep trying that one if you want, and putting some requests in there. But for now, let's keep moving. So you might be thinking, okay, this is really cool. We managed to actually steal some data from this poor archaeologist. But as I mentioned earlier, cross-site scripting is becoming less and less common, or at least like basic cross-site scripting has become less and less common because it's been around for long enough. People know that they need to protect against it, especially if you're using certain frameworks. They might do things for you, and they might just like deal with it for you. And like I mentioned, there are techniques that you can use to prevent this from being possible, like replacing those greater than and less than signs with the visually identical symbols that have no meaning to HTML or JavaScript. So most web developers know better than to take completely disgusting, unsanitized user input that could contain dangerous JavaScript and just like not do anything with it. This is called sanitization, trying to clean up the user input so that it's not dangerous. Alex said, the last time I used Pastebin, I accidentally stole someone else's URL and they did the challenge for me. Nice. You just sent your flag to them. Nice work. So if we take a look at some PHP, this is the code that would be running on the server side before it sends the request back to you. Here, it's checking for a GET request with a parameter called user bday. And it sets its internal variable bday to whatever was in here. So this is what was going on for number 2 for getGood. And then it just uses that variable on throughout the rest of the function without ever actually checking what was in it. This is, by the way, also why you guys were able to get all kinds of crazy dates to be accepted into the closed beta, because as soon as you guys put something in here that wasn't a number, and it tried to do this explode function, turns out that when this function gets something that's not a number, it just defaults to true. So this is where that vulnerability was coming in. It took this get user bday and then just used whatever data was inside of it without checking it. This is the way that it should be done in PHP. Here we see it's checking for a post request with a variable called name. And before it does anything with this post request name, it runs it through a function called HTML special characters. And this function does exactly what we talked about before, where it takes the less than sign, it turns it into a sequence of letters and numbers, like the ampersand LT semicolon. And then when it sends it back to your browser knows to take that string of characters and display it to you as though it were a bracket or an angle bracket, even though that combination of characters, the LT semicolon, doesn't mean anything. So if we were to put some JavaScript in here, when it echoed out, we would see our JavaScript just printed out to us as though it were a normal string, and nothing would happen. Our JavaScript wouldn't execute. It would just carry on its merry way, thinking that your name was script alert1 script. So like I mentioned, it's pretty rare that a server will completely fail to check for JavaScript. What's more common is to see a bad job, essentially. Sometimes you'll see things like a certain tag, like script, or an attribute, like onAlert, just being disallowed, and people thinking, oh, that's good enough. If you guys, I think mostly computer science students out there, if you guys were trying to approach the question of how do I prevent someone from being able to write dangerous JavaScript into my web app, you guys might say, oh, I've got you. I know what I would do. This is a job for a regex. Let's see what Google has to say about that. Stack Overflow, our favorite. Regular expressions to prevent XSS. You should filter input, sanitize data, encode HTML, and various other techniques. Basically, the answer is don't do this. Don't use regex. People are claiming that you can do it with a regex, but you can't. The reason is that, that there's actually a complex series of steps that's a little bit more nuanced than just like client, server, client. And there are a number of things that can go wrong during any one of those steps. So if you're thinking, oh yeah, I'll just use a regex, no, not good enough. It's actually a really challenging problem to figure out how to let users include certain maybe HTML tags, but to disallow all JavaScript. It's really difficult, and it's really easy to do a bad job. So for the final exercise for tonight, this one is a variation on the previous one. If we head over to exercise 4, this is the exact same goal. We want to steal a cookie. The difference is that this time the site is doing a little bit of processing on the back end to try to prevent XSS. Your hints to start you off are there's some filtering going on to try to keep you from being able to write JavaScript. That's the first thing to know. The second thing to know is that they've done a bad job. That maybe doesn't sound like a hint, but it is. There are some techniques that the server is using to try and prevent XSS, but it's not doing a very good job. So think about if you were the one writing this web app and you just wanted a really naive implementation of like, hey, how do I prevent people from XSS my site? Those are the kinds of things that are being done here. What I would recommend for you guys is build off of what you had before, build off the payload that we went through for exercise 3, and start to modify it and play with it. Start off by just like sending some requests, sending some smoke tests, and try to figure out what is allowed, what is being disallowed, and what is getting garbled. That should put you in a pretty good spot to start thinking about like, hey, what filters might be applied on the server side? This one should play a little nicer with smoke tests as well. So if you manage to get a smoke test through, that's a good indication that whatever you've got can be built up into the full cookie grabber. This one, I'm also going to give you guys a lot of time. Again, feel free to talk in chat or on Discord. Feel free to ask questions, and feel free to update with how you're doing and how you're feeling. 0 for this is super easy. Come on, let's get a move on. 9 for this is the hardest thing I've ever done. End it now. Tell me what to do. Gonna give you guys a lot of time, and I hope you have fun. And remember to use the hints and the resources page if you're getting stuck. How are people feeling? I've definitely seen some requests come through with folks getting the flag, which is awesome to see. But if you're still working on it, that's fine too. Let me know. Are you feeling ready for a hint? Do you want more time? All right, getting some requests for a hint. So if you're hard at work and you think you're really close and you don't want a hint, feel free to mute or go away and come back. But if you're feeling kind of stuck and you want a bit of a hint, let's take a look at one of my 50 million Chrome tabs. Okay. So the first hint is that that we've got some filtering going on. We know that it's not going to be as easy as just tossing a script tag in there. And sure enough, if we actually try putting a script in here, we find out that it's doing some really janky stuff. Like the word script is completely gone. Some of these brackets are gone too. And it starts to look like, okay, maybe they're doing some filtering on the other side that's disallowing some words. So why don't I just try the word script all by itself? Is the word allowed? Script is gone. Okay, so clearly the word script isn't getting through properly. But if you think about the person writing this code on the back end, and you think about how maybe you would write it if you were trying to strip out the word script, I wonder if there's a way to get by not being allowed to use a word. Are we allowed to do a different word? Oh, okay, it's blocking some attributes too. That might have to influence what kind of payload you use when you use payloads all the things. Some of these might have an on error. They might have on point over or pointer over. Looks like some of those words also aren't going to be allowed. And do you think that there is a way that you might be able to bypass that? Sean has a good point. It also seems to be escaping quotation marks. So again, that might have to influence what kind of payload you craft to either avoid those things or to get around them. All right, it's looking like some people are getting really, really close. So I don't want to cut you guys short when I see people making progress. But if you're feeling stuck and you think that you need another hint, feel free to let me know in the chat. And I've got one more hint that I can give you. All right, I'm going to give you guys 3 more minutes, and at quarter 2, we'll go over the solution. All right. So we're getting pretty close to the end here. Let's take a look at the solution and see if we can't launch this final XSS. So again, a good place to start is payload all the things. We know that we're looking for a cookie grabber or a cookie stealer. We might as well just try this first one again. And let's just do it with the localhost to start and see what happens. So again, we're getting lots of garbage in here. It looks like it's filtered out certain characters and not others. But good news, it looks like document.location is working, and it looks like document.cookie is working. So that's a good start. That's good to know. But we know that script is getting filtered. And if we think about this, this terrible dev who's trying to prevent cross-site scripting, we know that the dev is trying to prevent cross-site scripting, and we know that the dev is doing a really bad job. So maybe because the word script is getting filtered, maybe they're just running through the input, and if they encounter the term script, they're taking it out and then doing nothing else. And in fact, this is the backend code, which might give you a little bit of a hint. If you're almost there, this might be enough to help. They've got this list, script, on error, on mouse over, the same things that we couldn't get it to connect to, or we couldn't get it to process. And for each item in the list, it's just checking if this substring is in the user input, replace it with a null character. Just take it out. And that should be good enough, right? Not allowed to use the word script. How are you going to get JavaScript? So let's set up our paste bin while we're at it. Or our request bin. I prefer request bin. but you can use any one that you want. All right. And let's get to work on this payload. So we know that good portions of this are working. That's nice. We know that we're going to have to replace localhost. And then that one tricky bit, the script, document.location. We can't use script. But because it's just scanning through and checking for that one substring, and then moving on to the next thing, and then the next thing, and then the next thing, what if we split it up? So we know that if I try and put the word on error in here, on error gets taken out as well. So what if I break up the word script and put the word on error in the middle? Now, when the server-side code processes it, it's going to scan it through for the word script, not get anything. And then it's going to scan it through for on error, and it's going to find on error and delete it. And then we'll have the word script. So let's give it a shot. Oh, wow. Okay. This is weird. Now there's nothing. Well, why might there be nothing? JavaScript doesn't show in the page, so maybe it went through. Let's take a look. Refresh. Sure enough, we got a request, and we have our C variable set with that random PHP ID from the script and our cookie. So there are a couple of ways that you could have found this. If you scroll through payloads, all the things, it has a couple of examples of things like this. Times when you insert, do this exact thing, insert one term into another term to get past a filter. So you can find it in here. You can also Google your way to the top. That's always a good solution. Expergified says, I got it by making script. Yeah, that's another good point. If we go back to the source code. It's checking for this exact substring. So if it doesn't find lowercase script, then it's just going to let it through. So there are a whole bunch of ways that you could figure this one out. I always like the putting one term inside of another term, but the capitalization also works great. So if you're still working away at that one, I'll leave the script running for a little longer so that you can XSS my poor unsuspecting archaeologist. But just in the last couple minutes as we wrap up, this puts you guys in a pretty good position to understand what cross-site scripting is and how it works and how to identify it. Someone said that's way easier than putting script. That's true. The nice thing about putting it inside of itself is that if the filtering is non-case sensitive and maybe it does pick up on differences in case, then that second one, this script inside script, that will still get through. But you know what? Whatever works. If you can get it by capitalizing, get it by capitalizing. So yeah, you guys are in a pretty good spot to understand the basics of JavaScript cross-site scripting. Like I mentioned a couple times in this workshop, the very basic cross-site scripting attacks are normally pretty well protected against. But also, we saw the CVE list that shows that they're popping up all the time. There are all kinds of complicated XSS attacks, things like DOM-based attacks that rely on the file that you receive from the server being translated into something else by the time it's actually viewed by you in your browser. There are a couple of steps that happen there that you can exploit. There are things like XSS, where things get modified along the way as they get passed through to different steps between the server and the client. And those things still pop up all the time. But this puts you in a pretty good position to understand what cross-site scripting is and why it's dangerous. If you're ever doing XSS in a CTF, payloads all the things is like my go-to for everything in a CTF where you have to send a payload. They're awesome and you can modify them to work for your purposes. Request bin is also great. You can use post bin too and other ones. I just like request bin because it's really, really simple. Burp Suite is a tool that we didn't go into today, but if you have Kali Linux, you can fire it up and take a look. Burp Suite lets you intercept the HTTP requests as they go. Client makes a request to the server, server sends information back to the client. Burp Suite lets you interrupt it before it gets to the server and mess around with the parameters. And you can use that if you're trying to send post requests or if you're trying to do more complicated web exploitation. And that's it for tonight. So I hope you guys learned something. I hope that you enjoyed yourselves and you got some flags. Make sure to sign the attendance sheet. Make sure to sign up for the CTF if you're interested. I don't know, do we have any other announcements? That's just about it for me. I'm not receiving any word from any other execs in my ears telling me to make more announcements. So I'm going to leave the script running for this final challenge up for a little while. If there's anyone who still wants to try it, feel free, try to mess around with different ways to get the payload through, and see if maybe you can do it with a different payload than the document.location. Yeah, give it a shot, see what you can find. One final thing is that next week we have another workshop, and it's going to be Brandon. He's going to be teaching shellcode, which should be really cool as well. So next week, shellcode. Week after that, Adam Mcmath speaker series. Got a good lineup of stuff coming. Good night, guys.